Look up. It's late, and you're standing somewhere quiet enough that the sky actually shows itself: a backyard, a hiking trail, the hood of a car pulled over on some dark stretch of highway. The stars are doing what they've always done, which is nothing, technically. They're just sitting there, burning, indifferent to whether anyone below is watching. But you're watching. And there's a particular kind of vertigo that comes from really looking, not the glance you give the sky on your way from the car to the front door, but the sustained look, the one where your eyes adjust and more stars keep arriving the longer you stare, filling in the gaps like a photograph developing. At some point the scale of it stops being scenery and starts being a problem. A question with teeth. Because what you're looking at isn't a ceiling. It isn't a painted dome arranged for your benefit. It's depth. Actual, staggering depth, and every point of light up there is a fact about somewhere else, some of it so far away that the light hitting your eyes left its source before humans had cities, before we had language, before there were humans at all. You are, in a very literal sense, looking into the past every time you look up, and the past you're looking into doesn't end where your vision runs out. It just becomes light too faint to see, and behind that light more darkness. And behind that darkness, if certain physicists are right, more of everything, more stars, more galaxies, more darkness, more everything without end. Maybe you've had a version of this moment before. Most people have, at least once some night when the ordinary business of being alive quiets down just enough for the sky to actually get through, past the noise of whatever the day was about, past the phone, past the errands, past the small persistent hum of being a person with a schedule and a name and a set of things to worry about tomorrow. In that quiet, the sky stops being a backdrop and becomes, briefly, the main event. And the first thing most people feel, looking up like that, is smallness, a familiar, almost comfortable kind of smallness, the sort that comes with any encounter with something much bigger than yourself: the ocean at night, a mountain range, a cathedral ceiling. It's humbling in a manageable way. It fits inside the category of awe, and awe, however intense, is a feeling most people know how to hold. But if you stay with it a little longer than usual, if you let the question of scale actually follow its own logic instead of stopping at the universe is big, the feeling starts to shift into something less comfortable, something closer to vertigo than awe. Because big turns out to be the wrong word entirely for what's actually being suggested, once you follow the physics and the mathematics all the way to where they're honestly pointing. Big has an edge, even if the edge is very far away. Big can still be held, conceptually, the way you can hold the idea of a very large number without it threatening anything about how you think of yourself. What starts to come into view instead, the longer you sit with the actual science, isn't bigness. It's a total absence of edge. And an absence of edge changes the nature of the question completely, because once there's no boundary left to run into, certain strange mathematical consequences stop being optional. They become, given enough space and enough time, unavoidable. That's the thought this comes down to, eventually. Not tonight, standing under the sky, feeling small in the ordinary way people feel small under stars. Something else. Something worse or stranger, depending on your temperament. Because if space really does go on forever, not just very far, not just farther than we can see, but forever, without edge or limit, then a strange kind of arithmetic starts to kick in. An arithmetic that doesn't care about your intuitions, that doesn't slow down to let you catch your breath, and that seems to end, if you follow it honestly, at a conclusion most people have never had to sit with, that somewhere out past the reach of every telescope we will ever build, there might be another Earth. And on that Earth, another person, living your exact life, thinking your exact thoughts, reading, perhaps, something very much like this sentence at this exact moment, for reasons that are entirely their own and entirely yours. Let's build up to that carefully, because it deserves care. It's the kind of idea that sounds like science fiction until you look at the actual physics and actual mathematics underneath it, at which point it stops sounding like fiction and starts sounding like something you have to take seriously, even if you end up rejecting it. So we'll start small. We'll start with the ground under your feet and we'll expand outward in stages, the way the universe itself seems to have done until the scale becomes almost unbearable, and then we'll ask what it means for the person standing there at the very beginning, looking up, feeling the first edge of that vertigo settle in. Start with the Earth. It seems enormous from where you're standing, an entire planet, 4,000 miles or so from surface to core, wrapped in oceans and mountain ranges and cities that took millennia to build. When you're inside it, when you're a single organism walking around on its crust, the Earth reads as the whole of reality, or close enough. Ancient cosmologies tended to agree on this, whatever else they disagreed about. The Earth was the stage, and the sky above it was decoration, sometimes literal, a canopy, a set of crystal spheres, a roof with holes punched in it for stars to shine through. That was a reasonable guess, given what people had to work with. It matched the evidence available to the naked eye. It also happened to be almost unimaginably wrong. Because it turns out the Earth is not the whole of reality. It isn't even a particularly large slice of it. The Earth is a rocky ember orbiting a mid-sized star in a fairly unremarkable spiral arm of a galaxy that contains somewhere on the order of 200 billion other stars, most of them with their own retinues of planets, most of those planets utterly indifferent to whatever is or isn't happening on the third rock from a star we happen to call the Sun. And that galaxy, the Milky Way, 100,000 light-years across, so vast that light itself, the fastest thing there is, takes 100,000 years just to cross it. That galaxy is itself one among roughly 2 trillion other galaxies, according to recent estimates from deep field imaging, each with its own hundreds of billions of stars, each swimming through space in clusters and superclusters strung out like beads on a cosmic web that stretches for billions of light-years in every direction anyone has managed to look. That's the first vertigo, and it's the one most people encounter at some point in a classroom, in a documentary, in a moment exactly like the one we started with, standing outside at night doing the math badly in your head and getting nowhere because the numbers refuse to mean anything. The Earth is not the universe. The Earth is barely a rounding error. And once you've absorbed that, once you've let the scale actually land instead of just nodding along to it as a fact you're supposed to already know, a second question tends to surface right behind it. How far does this go? Where does it end? And that question turns out to be far stranger than it first appears, because the honest answer isn't a number. The honest answer is that we don't know, and worse, we may not be able to know, and worse still, the reason we can't know might not be a limitation of our instruments. It might be a limitation built into the structure of the universe itself. Here's why. When you look into deep space, you're not just looking far away, you're looking backward in time, because light isn't instantaneous. It travels fast, but not infinitely fast, and so the light reaching your eyes from a galaxy 10 million light-years away left that galaxy 10 million years ago. The image you're seeing is a fossil. A very fast fossil, but a fossil all the same. This means that the farther out you look, the further back in time you're looking, and there's a limit to how far back you can go, because the universe itself has a finite age. According to the current best estimate based on measurements of the cosmic microwave background, the leftover radiation from an extremely hot, extremely dense early state of the universe, that age is about 13.8 billion years. Which means, naively, that the farthest anything could be from us and still be visible is about 13.8 billion light-years, because that's how long light would have had to travel to reach us since the beginning. Except it's not that simple, and the complication is worth sitting with because it's the hinge on which the rest of this argument turns. The universe has been expanding this whole time, not just galaxies flying apart through existing space, but space itself stretching, growing, carrying galaxies along with it, the way raisins in a rising loaf of bread get carried farther apart from each other as the dough itself expands, without any raisin actually moving through the dough. That distinction matters enormously. Because space hath been expanding for the entire 13.8 billion years, light has been traveling toward us. The light that left a distant galaxy near the beginning of time has had to cross a gap that kept growing even as the light was crossing it. By the time that light finally reaches us, the source that emitted it isn't 13.8 billion light years away anymore. Due to the expansion, it's now roughly 46 billion light years away. Present distance, not light travel distance. Cosmologists call this the particle horizon, and it defines the edge of what's called the observable universe, a sphere centered on us with a radius of about 46 billion light years in every direction. 92 billion light years across, then, roughly. That's the observable universe. That's everything we can, in principle, ever detect because it's everything whose light has had time to reach us since the universe began. It contains, by current estimates, those 2 trillion or so galaxies, unfathomable numbers of stars, unfathomable numbers of planets, and it is, again, almost impossible to hold in the mind as an actual quantity rather than a phrase you repeat. But here is the crucial thing, the thing that turns this whole discussion from a lesson in humility into something closer to an existential trapdoor. The observable universe is not the universe. It's just the part of the universe we happen to be able to see, given where we're standing and how old the cosmos happens to be at this particular moment. It's a horizon, not a wall. And horizons, by definition, are relative to the observer. Someone standing on a hypothetical planet 40 billion light years away from us has their own observable universe, their own 92 billion light year sphere centered on them, and it overlaps with ours only partially. Most of what they can see, we can't. Most of what we can see, they can't. Neither of us is seeing the edge of reality. We're each seeing the edge of our own vantage point. There's a further wrinkle worth adding here, because it changes how strange the observable universe really is. The particle horizon isn't fixed. It grows slowly as more time passes and more distant light finally has the chance to complete its journey to us. Every year, a little more of the previously unobservable universe becomes, in principle, observable, new light arriving that left its source a little farther away a little longer ago. So the boundary we're describing isn't a wall standing at a fixed location in space. It's a moving frontier expanding outward from us at something close to the speed of light, carrying more and more of the universe into view as it goes, even while the runaway expansion of space itself is simultaneously carrying certain distant galaxies beyond any hope of ever being reached, their light forever trapped en route, never quite arriving, stretched into wavelengths so long they become undetectable before they get here. 2 processes running in opposite directions at once, our horizon growing, and some galaxies receding beyond any horizon's reach entirely, regardless of how long we wait. It's a strange kind of universe, one where what we can see is neither fixed nor complete, and where what we will ever be able to see is a smaller, sadder number than what actually exists, possibly by a margin too large to measure. So the real question isn't how big is the observable universe. We know that roughly. The real question is what's out there past that horizon, in the part neither of us nor anyone can ever observe. And here cosmology runs up against a genuinely strange epistemic situation, because there is, by construction, no direct way to find out. Whatever is past the particle horizon has never sent us any light, any signal, any information of any kind, and given the ongoing expansion of space, it never will. Regions far enough away are receding from us faster than light can cross the intervening space, which sounds like it violates relativity, but doesn't, because it's the space itself expanding, not any object moving through space faster than light. Those regions are, for all practical purposes, permanently and irrevocably cut off from us. We will never see them. We will never get a signal from them. Any civilization living there, if one exists, is in exactly the same position relative to us. We don't exist as far as their instruments are concerned, and never will. Given that total observational silence, you might expect cosmologists to shrug and say the question is meaningless, unanswerable, unscientific, off the table. But that's not quite where the field has landed, and the reason is that we're not entirely without evidence. We have indirect tools. The two most important ones are the measured geometry of space and the theory of cosmic inflation, and both point, cautiously but persistently, toward the universe extending well beyond, potentially infinitely beyond, what we can see. Take geometry first. One of the deep insights of general relativity, Einstein's theory of gravity, is that space itself can be curved, and the overall curvature of the universe determines its large-scale shape and, potentially, its size. There are three basic possibilities. Positive curvature, like the surface of a sphere, which would make the universe finite but unbounded. You could travel far enough in one direction and eventually come back to where you started, the way sailing far enough east eventually brings you back west. Negative curvature, like the surface of a saddle, which corresponds to an infinite, ever-expanding space. And zero curvature, flat space in the geometric sense, which is also, generically, infinite, extending forever in every direction like an endless sheet of paper. Precision measurements of the cosmic microwave background, particularly from the Planck satellite mission, have measured the curvature of the observable universe with remarkable accuracy, and the result is that it is flat, or so close to flat that any deviation is smaller than our current instruments can detect, consistent with exactly zero curvature within the margin of error. That's suggestive, not conclusive. It's possible the universe has some very slight curvature that would only become detectable if we could see much farther than we currently can, which would imply a finite, if enormous, universe. But the data we have is entirely consistent with the universe being spatially infinite, and flat space extending forever is, in fact, the simplest and most natural reading of the measurements as they stand. Then there's inflation, a theory developed initially by physicist Alan Guth in the early 1980s, later extended by researchers including Andre Linde, which proposes that in the first fraction of a second after the Big Bang, the universe underwent an extraordinarily rapid period of exponential expansion, space itself stretching by a factor of something like 10 to the 26th power or more in a time frame shorter than a trillionth of a second. Inflation was proposed to solve several stubborn problems in cosmology: why the universe looks so uniform in every direction, why its geometry is so close to flat, why we don't see certain theoretically predicted relics from the early universe. It's since become one of the best supported frameworks in cosmology, consistent with an enormous range of observational data, even though the details of exactly what drove it remain unsettled. One of the natural consequences of most inflationary models is that the region of space we can observe, our entire 92 billion light-year sphere, is only a vanishingly small patch of a much larger space that inflated along with it, a space that, in many versions of the theory, is effectively infinite, or at least vastly larger than anything we could ever hope to observe even in principle. In some versions of inflationary theory, this goes further still. Inflation may not have stopped everywhere at once. It may still be happening in most of space, with our observable universe being one bubble among an unfathomable number of other bubbles, each one a separate expanding region, each potentially with its own physical constants, its own local conditions, a picture sometimes called eternal inflation, developed largely by Linde and others building on Guth's original work. Under eternal inflation, our observable universe isn't just a small piece of a bigger single universe. It's one pocket among infinitely many pockets, embedded in something too large and too strange to really be called a universe at all. Cosmologists usually reach for the word multiverse instead, though it's worth saying clearly that this remains a theoretical extrapolation, not a directly confirmed fact, and serious researchers disagree about how seriously to take it. It's worth pausing here to note that eternal inflation, if taken seriously, produces a picture of reality considerably stranger than one big infinite universe. Max Tegmark has proposed organizing this kind of speculation into a rough hierarchy of levels, useful less as a confirmed taxonomy than as a way of keeping the different claims separate so they don't blur into one another. What we've been describing so far, an infinite, uniform space beyond our observable horizon, governed by the same physical laws and the same fundamental constants we measure locally, is what Tegmark calls a level I multiverse. It's the most conservative version of the idea, requiring only that space be infinite and that our local laws of physics extend uniformly through it, both reasonably mainstream cosmological possibilities. Eternal inflation, with its endlessly budding bubble universes, each one potentially settling into different local physical constants, different effective laws, describes something Tegmark calls a level Roman II multiverse, a much stranger and more speculative proposal, since it would mean the duplicate you question doesn't even apply uniformly, because most of those other bubbles might have chemistry, gravity, or particle physics too different from ours to produce anything resembling a planet, let alone a person. There are further levels still, involving the many worlds, interpretation of quantum mechanics, and, at the most speculative end, purely mathematical structures existing as physical realities in their own right, proposals that stray increasingly far from anything resembling settled physics and increasingly close to pure philosophical conjecture. It's worth keeping this hierarchy in view specifically because tonight's argument leans only on the most conservative rung of it, level I, an infinite extension of the one universe we already know the physics of, not on the far more exotic and far less evidence levels above it. The case for a duplicate you doesn't require multiverses in the more exotic sense at all. It only requires that this universe, the one we're already living in, with its stars and its physics unchanged, simply doesn't stop. None of this is settled science in the sense that, say, the roundness of the Earth is settled. Inflationary multiverse theory in particular remains difficult to test directly, and some physicists have raised sharp objections to it on exactly those grounds, that a theory which predicts things we can never observe starts to strain against what counts as science at all. That's a real and important criticism, and it deserves to be taken seriously rather than waved away. But the more modest claim that space very likely extends significantly beyond the observable universe, and quite possibly extends infinitely given a flat or negatively curved geometry, that claim rests on solid enough observational footing that a large portion of the cosmological community treats it as a live and reasonable possibility, not a fringe fantasy. So let's take it seriously, at least provisionally, as the premise for a thought experiment worth following all the way to its conclusion. Suppose space really is infinite, not unimaginably large, not larger than we can currently measure. Actually, literally, without end, infinite, extending forever in every direction, filled with more galaxies, more stars, more everything, without any boundary or edge at all. If that's true, something strange and mathematically unavoidable starts to happen, and it isn't really new, it's an old idea dressed in modern cosmological clothing that stretches back centuries before anyone had a telescope powerful enough to see even the edge of our own galaxy. The Roman poet and philosopher Lucretius, writing in the 1st century BCE, built an entire cosmology on the atomism of Epicurus, and before him Democritus, arguing that the universe consists of an infinite number of atoms moving through infinite void, and that given infinite atoms in infinite space, it would be absurd, his word, essentially, to think our world was the only one, or even a unique one. If matter is infinite and space is infinite, he reasoned, then somewhere, sometime, matter must arrange itself again in configurations similar to our own, because there is nothing about our particular corner of the universe that is special enough to be unrepeatable. It's a startlingly modern argument, made without telescopes, without any way to verify it, purely on the logic of infinity itself. Lucretius wasn't reasoning from observation. He was reasoning from what infinity necessarily implies once you accept the premise. More than a millennium and a half later, the Italian philosopher and Dominican friar Giordano Bruno picked up a version of the same thread and pushed it much further, at considerable personal cost. Bruno, working in the late 16th century, proposed not just that the universe was infinite but that it contained countless suns, each likely with its own planets, and that some of those planets might harbor life just as our own does. He rejected the idea that Earth or the Sun held any privileged position in the cosmos. In a universe without center, without edge, every world was, in principle, as ordinary as any other. This was a radical, dangerous position to hold in the intellectual climate of the time, entangled as it was with deep theological questions about creation, uniqueness, and humanity's special place in it. There's a detail worth sitting with in how Bruno framed the emotional stakes of his own cosmology, because it anticipates almost exactly the split we still feel today between awe and dread when contemplating the same idea. Bruno didn't treat an infinite universe as a diminishment. He treated it as a kind of liberation, a vastly larger and more generous conception of divinity and creation than a small, closed, earth-centered cosmos could ever have offered, on the reasoning that infinite creative power ought to produce infinite creation, not a single cramped stage with everything else left empty. Whether or not you share his theological framing, the emotional move he's making is worth noticing because it's one of exactly two available responses to this whole subject, then and now. You can meet the scale of an unbounded universe with dread as a threat to your uniqueness and your significance. Or you can meet it, as Bruno did, with something closer to expansive wonder, treating the sheer scale not as an insult to your importance but as a fact largely indifferent to the question of importance altogether, which frees you to locate meaning somewhere other than in cosmic rarity. Bruno's death didn't settle which of those responses is correct. 4 centuries of physics since haven't settled it either. It remains, even now, less a scientific question than a temperamental one, a choice about which lens to hold up to the same set of facts. Bruno's cosmology was only one strand among several unorthodox positions that eventually brought him before the Roman Inquisition, and in 1600 he was burned at the stake in Rome. His death wasn't purely, or even primarily, about his views on infinite worlds. The historical record shows a tangle of theological disputes at the center of his trial, but the infinite worlds cosmology was very much part of the package of ideas the Church found intolerable, and Bruno has since become something of a symbolic martyr for the idea of cosmic plurality, the notion that we are not, and cannot be, alone or unique in an unbounded universe. It's worth pausing on that because it says something about how uncomfortable this idea has always been, long before modern physics gave it any observational grounding at all. The claim that the universe might be infinite, and that this implies the existence of other worlds, possibly other versions of familiar things, has never been merely a scientific curiosity. It has always carried an edge of vertigo, a threat to whatever story a given era tells itself about its own uniqueness and importance. Bruno paid for that threat with his life. We get to entertain it from the comfort of a night sky and an internet connection, but the underlying discomfort is exactly the same discomfort, just with better instruments behind it now. Because here's the modern, rigorous version of Lucretius's argument, and it's worth walking through slowly, because the logic is genuinely airtight once you accept the premises, even if the premises themselves remain open to challenge. Matter in the universe, as far as we understand it, is organized out of a finite set of particle types, quarks, electrons, photons, and so on, governed by physical laws that appear, as best we can measure, to be the same everywhere within the observable universe. Now, take any finite region of space, say, a region the size of the observable universe itself, roughly 92 billion light-years across. Within that finite region, even though the number of particles is staggeringly large, something on the order of 10 to the 80th power atoms by common estimates, the number of possible arrangements of that matter is still, crucially, finite. Enormous, almost incomprehensibly enormous but finite. This is because there's a limit to how finely matter can be arranged given quantum mechanical constraints. There's a smallest meaningful unit of position, of energy state, of configuration, below which the universe doesn't seem to distinguish between two states as being different from each other at all. Physicist and cosmologist Max Tegmark, along with others working in this area, has estimated the number of distinct possible arrangements of matter within a Hubble volume, a region the size of the observable universe, as an astronomically large but still finite number, something on the order of 10 raised to the power of 10 raised to the power of 118, give or take, depending on the exact assumptions used. It's a number so large that trying to visualize it is pointless. It dwarfs the number of atoms in the observable universe by margins that make astronomical feel like an insult to the actual scale involved. But, and this is the entire hinge of the argument, it is still, technically, finite. A number, not infinity. A very large room, not an endless one. Now suppose space itself is infinite, as the flat geometry measurements and the inflationary models both suggest it plausibly could be, and suppose that matter is distributed throughout that infinite space in a roughly uniform way on the largest scales, which is itself a well-supported observation, called the cosmological principle. The idea that the universe looks statistically similar in every direction and at every sufficiently large scale, without any special centers or edges. If both of those things are true, infinite space and a finite number of possible local configurations of matter repeated across that infinite space, then basic probability forces a conclusion that sounds almost too strange to be a mathematical necessity rather than a wild guess. If you have a finite number of possible configurations and an infinite number of regions in which those configurations can occur, then every possible configuration that has a non-zero probability of occurring must occur again. Not might. Must with probability 1 given infinite trials. This is closely related to a mathematical idea sometimes illustrated with a thought experiment called the infinite monkey theorem, the observation that a monkey typing randomly on a keyboard forever will, given infinite time, eventually type out the complete works of Shakespeare, not because it's likely on any given attempt, but because with infinite attempts every possible finite string of text that has any chance of occurring will occur, and in fact will occur infinitely many times. Apply that same logic to space instead of time, to physical configurations of matter instead of keystrokes, and the conclusion Tegmark and other cosmologists have drawn, following essentially the same argument Lucretius sketched 2,000 years earlier, is this: if space is infinite and matter is distributed throughout it in a statistically uniform way, then somewhere out there, vastly, unimaginably far away, likely far beyond even the boundary of the observable universe, but somewhere there exists another region of space with an arrangement of matter identical, or close enough to identical as to make no difference to the arrangement of matter that makes up our observable universe. Another Milky Way, another Sun, another Earth with the same continents, the same oceans, the same history, right down to the same person standing outside on a quiet night looking up at a sky and thinking the same thoughts. And because the argument depends on infinity rather than any particular finite probability, it doesn't happen just once. Given a truly infinite space and a finite set of possible configurations, an exact duplicate of you, your street, your entire observable universe occurs not once somewhere out there, but infinitely many times, over and over, scattered through the endless expanse at distances so large that the numbers describing them cease to have any intuitive meaning at all. Tegmark, in some of his published estimates, has put a distance on this, noting that the nearest identical copy of you, under these assumptions, would likely be found something on the order of 10 to the power of 10 to the power of 118 meters away, a number of meters so large that writing it out digit by digit would itself require a universe's worth of paper. It's important to be honest about what kind of number that is. It's not a measured distance. It's not something derived from a telescope. It's a theoretical estimate that follows from combining a set of assumptions: flat infinite space, a roughly uniform cosmological principle, finite information density, that are individually reasonable and individually supported to varying degrees by observation, but which nobody has verified in combination, and which some cosmologists reject outright, either by doubting the infinite extent of space or by doubting the uniform distribution of matter at those unimaginable scales. This is, in other words, a rigorous extrapolation built on genuinely uncertain premises, not a settled discovery, but not empty speculation either. It sits in that uncomfortable middle zone that a lot of the most interesting ideas in cosmology occupy, testable in principle only through the internal consistency of the models that produce them. But let's sit with the implication anyway, because even as a conditional, if space is infinite and matter is roughly uniform, then this follows. It's worth taking all the way to its conclusion, because the conclusion doesn't stop at another Earth. It keeps going past duplicate planets into something much harder to hold at arm's length, another you. Think about what you actually consists of physically. Set aside for a moment any question of souls, of some non-physical essence tucked inside the machinery. Set it aside not to dismiss it, but because the argument we're following doesn't need it and works entirely at the level of physical configuration. You are, as far as physics is concerned, an arrangement of matter, trillions of cells, organized into tissues and organs, chief among them a brain built from roughly 86 billion neurons, connected by something on the order of 100 trillion synapses, each one calibrated by a lifetime of experience into a particular pattern of connections that encodes your memories, your habits, your personality, your sense of who you are. That pattern is enormously complex, but it is not infinitely complex. It's a physical structure, made of physical stuff, arranged in a particular way, and like any physical structure, it falls within the same combinatorial argument that applies to the arrangement of a Hubble volume as a whole. The number of possible configurations of a human brain, while staggeringly large, is finite. Which means that under the same premises, infinite space, finite local configurations, uniform distribution of matter, a brain identical to yours, embedded in a body identical to yours, embedded in a planet identical to yours, embedded in a history identical to yours, all the way up to this exact moment, must exist somewhere in an infinite universe, and must exist infinitely many times. This is the point where the thought experiment stops being comfortable in the way that there are 2 trillion galaxies is comfortable or inspiring, but ultimately abstract, something you can admire from a safe conceptual distance. Another you isn't abstract in the same way. If the argument holds, there is right now, in some sense, though right now gets complicated across cosmic distances, a person somewhere in the universe whose brain holds the exact same memory you have of your first day of school, the same argument you had with a parent at 16, the same private, unspoken thought you had 5 minutes ago that you've told no one. Not a similar person. Not someone who resembles you the way a sibling or a stranger with your face might resemble you. An identical configuration, a physical duplicate down to the synapse, produced not because anyone built them deliberately, and not because of any causal connection to you whatsoever, but purely because infinite space, combined with a finite palette of possible arrangements, guarantees repetition given enough room to repeat in. And if you accept that, you have to accept something stranger still, which follows from the exact same logic without any additional assumptions. It isn't just one duplicate. If infinite space guarantees one exact copy of you, it guarantees infinitely many. Beyond the first duplicate, at some larger distance, is another. And beyond that, another and another, forever an infinite series of exact copies of you scattered through an infinite universe at distances that grow so enormous between each successive copy that no signal, no light, no information of any kind will ever pass between any of them. Each one from its own perspective, standing on its own version of Earth, believing itself, with total justification, given that its brain state is identical to yours, to be the only you there is. At this point it's worth naming the discomfort directly, because it's not merely an intellectual discomfort about very large numbers. It's a discomfort about identity, about what makes you the specific person you are rather than a replaceable instance of a pattern that could, in principle, be run anywhere by anything made of any matter, so long as the arrangement matches closely enough. That discomfort has a long history in philosophy entirely separate from cosmology, and it's worth bringing that history in now because it turns out philosophers were worrying about exactly this problem: what happens to personal identity when duplication becomes possible, long before cosmologists gave the problem a physical setting to occur in. The 17th century philosopher John Locke, in his essay concerning human understanding, proposed an influential account of personal identity grounded not in the physical body or some persisting soul substance, but in psychological continuity, specifically in memory. On Locke's account, what makes you the same person as the child who existed 20 years ago isn't that you're made of the same atoms, since your body has replaced nearly all of its constituent matter many times over through ordinary biological turnover. What makes you the same person is a continuous chain of memory and consciousness linking that child to the person reading this now. It's a theory built to solve a puzzle about identity over time, but it runs into serious trouble the moment you introduce duplication, because if memory is what grounds identity, and two physically distinct beings both possess in full the identical memories, Locke's framework doesn't obviously have the resources to say only one of them is really you. It has no built-in tiebreaker. The Scottish philosopher David Hume went further and in a different direction, arguing in his treatise of human nature that when he searched inward for some persistent self behind his thoughts, feelings, and perceptions, he never actually found one, only a bundle of perceptions succeeding one another, with no unifying substance underneath holding them together into a single, continuous self at all. On Hume's account, the self isn't a thing you have. It's a story you tell, stitched together retrospectively out of a flow of experiences that has no metaphysical glue beyond the narrative your mind imposes on it after the fact. If Hume is right, the question which duplicate is really me may already be malformed at the starting line, because it presupposes a kind of unified, trackable self that never existed to begin with, even in the ordinary, non-duplicated case. But the philosopher who engaged with this exact problem most directly and most rigorously was the 20th century Oxford philosopher Derek Parfit, whose work on personal identity in his book Reasons and Persons remains probably the most serious sustained philosophical treatment of duplication and identity available. Parfit used thought experiments involving teleportation to probe the question with a level of precision earlier philosophers hadn't had the vocabulary for. Imagine, he suggested, a teleporter that works by scanning your body down to the last atom, transmitting that information to Mars, and reconstructing an atom for atom duplicate there, while destroying the original on Earth in the process. Most people's first instinct is to treat this as a form of travel. You step in on Earth, you step out on Mars, same person, different location. But Parfit pushed further. What if the scanner malfunctions, and instead of destroying the original, it leaves you alive on Earth while still creating the duplicate on Mars? Now there are two of you, both with equal claim to being the continuation of the person who stepped into the machine, both carrying identical memories up to the moment of scanning, both diverging into separate individuals from that point forward. Parfit's conclusion, argued across hundreds of pages with a rigor most thought experiments never receive, was that our ordinary, intuitive notion of personal identity, the sense that there is a single, determinate fact of the matter about which future person is you, doesn't survive contact with cases like this. What matters, Parfit argued, isn't identity in some strict, all-or-nothing metaphysical sense. What matters is psychological continuity and connectedness, and that continuity can, in principle, branch. It doesn't have to pick a single winner. Cosmic duplication of the kind implied by an infinite universe is essentially Parfit's teleporter case, except stripped of the machine, the science fiction premise, and the neat causal story connecting the original to the copy. There's no scanner, no transmission, no shared moment of departure. The duplicate elsewhere in an infinite universe wasn't produced from you at all. There is no causal link between you and it whatsoever. It arose independently out of the same statistical inevitability that produces a duplicate solar system or a duplicate arrangement of dust in some other unreachable corner of space, purely because the same finite deck of possible configurations have been dealt out again, blind chance landing on the same hand twice. It is not you having traveled. It is not you copied. It is simply another instance of the same pattern existing without ever having had any contact with the instance you happen to occupy. This is in some ways an even harder case for personal identity than Parfit's teleporter, because Parfit's case at least has a clear causal chain running from the original person into both resulting people, a scan, a transmission, a shared history up to the moment of division. Cosmic duplicates share nothing of the kind. They share only a pattern arrived at independently, the way two people on opposite sides of the planet might, without any communication whatsoever, arrive at the identical solution to the same math problem, not because one copied the other but because the structure of the problem simply has only one solution, and both minds, working from the same starting conditions, found it. Except here the problem being independently solved isn't a math puzzle. It's an entire life. A childhood, a set of relationships, a specific afternoon a decade ago that you thought was yours alone, replicated not through any transfer of information but through the same cosmic dice landing elsewhere on the same numbers. The 17th century philosopher Gottfried Wilhelm Leibniz offers a useful, if unsettling, lens to push against here. Leibniz proposed a principle known as the identity of indiscernibles, the idea that no two distinct objects can share every single property in common. If two things are truly identical in every respect, they aren't two things at all, but one thing described twice. Leibniz illustrated this with a story, possibly apocryphal, about a garden where a princess challenged philosophers to find two leaves that were exactly alike, and none could, because in Leibniz's view no two leaves in the whole of nature ever are. Nature, on his view, simply doesn't repeat itself down to the finest detail, not because of any law forbidding it, but because the world is, in his framework, structured in a way that guarantees sufficient variation. If Leibniz is right as a matter of metaphysical necessity, cosmic duplicates might be impossible on principle, not merely improbable. Perhaps something about the deep structure of reality prevents true, exhaustive repetition even across infinite space in ways the simple combinatorial argument from physics doesn't capture, because physical position itself might count as a property that differs, making the duplicate merely similar rather than strictly identical in Leibniz's sense. That's a real philosophical escape hatch, and it's worth taking seriously rather than dismissing as a technicality, because it points to a genuine ambiguity sitting underneath the whole cosmological argument. Does location count as part of an object's identity? If two brains have identical arrangements of matter but exist at different points in space, are they truly identical objects, or merely qualitatively identical objects, same in every describable feature except one, the brute fact of where they happen to be? Philosophers distinguish these as numerical identity, being one and the same entity, versus qualitative identity, being two entities that are exactly alike in every respect. The cosmological duplication argument, as physicists like Tegmark present it, is really only claiming qualitative identity, that there exists elsewhere in infinite space another brain in every measurable respect identical to yours, right down to its momentary quantum states within whatever tolerance quantum indeterminacy allows. It doesn't claim numerical identity, that other brain isn't you, occupying two places at once, the way Leibniz's framework might, on a strict reading, forbid entirely. It's a second thing, a qualitatively perfect twin, separated not by a delivery room but by a distance too vast for the word separated to carry its ordinary meaning. But does that distinction actually help when you sit with it? Suppose I told you that somewhere on Earth right now, there existed a second body, molecule for molecule identical to yours, housing a brain molecule for molecule identical to yours, right down to the neural firing pattern occurring in it at this exact instant, a perfect qualitative duplicate, not numerically you, just a separate entity that happens to be indistinguishable from you in every conceivable respect. Would that feel like a curiosity about someone else, or would it feel like a direct assault on whatever you mean when you use the word I? Most people, sitting with that scenario honestly, report the latter. There's an old puzzle that sits usefully alongside this one, even though it approaches identity from a completely different angle. The ship of Theseus, described in ancient sources discussing the ship supposedly preserved by the Athenians in honor of the mythical hero Theseus, asks what happens to an object's identity when its physical parts are gradually replaced, one plank at a time, until eventually none of the original material remains. Is the fully replaced ship still the same ship? The puzzle is usually treated as a question about persistence through time, how much change an object can undergo while still counting as the same thing it was before. But it has a quieter implication for tonight's question too, because your own body has already run this experiment on you many times over, without anyone needing an infinite universe to arrange it. The atoms making up your body today are, to a significant extent, not the same atoms that made it up a decade ago. Most tissues replace their constituent matter on a rolling basis, some cells within days, others across years, until very little of the original physical material persists at all. If the ship of Theseus can remain the same ship through total material replacement, then whatever makes you the same you across a decade was never simply a matter of being built from the same atoms in the first place. It was always about something more like pattern, structure, and continuity of process, the plank-by-plank shape of the ship rather than the particular wood it happens to be made of at any given moment. Which means the cosmological duplicate, made of entirely different atoms arranged in the same pattern in a distant, unreachable region of space, isn't actually doing anything more radical to the concept of you than your own metabolism has already done, quietly, your entire life, one replaced cell at a time. The strangeness of the duplicate isn't that it's made of different matter. Ordinary you is already made of different matter than ordinary you from 10 years ago. The strangeness is only that the duplicate's different matter got arranged into the identical pattern somewhere else, all at once by chance, rather than gradually, in one place by biology. There's a related puzzle from contemporary philosophy of probability worth bringing in here, because it captures something about tonight's question that the duplication argument alone doesn't quite reach. Not is there another you, but given that there might be, what should you believe about which one you are right now as you sit with the question? Philosophers call this a problem of self-locating belief, and one of the cleanest illustrations of it is a thought experiment usually called the Sleeping Beauty problem, developed and debated extensively in the philosophical literature on probability and self-location. In its standard form, Sleeping Beauty agrees to a strange experiment. She'll be put to sleep, and a coin will be flipped. If it lands heads, she'll be woken once, on Monday, and the experiment ends. If it lands tails, she'll be woken on Monday, have her memory of that waking erased, and then woken again on Tuesday, so that from the inside, the Monday tails waking and the Tuesday tails waking feel completely indistinguishable from each other, and both feel indistinguishable from the single heads waking. Each time she wakes, she's asked, "What's your credence that the coin landed heads?" The puzzle has generated a genuine, unresolved split among professional philosophers of probability between those who argue the answer should be one half, treating the coin flip as an ordinary 50-50 event, and those who argue it should be 1/3, on the reasoning that there are 3 possible wakings in total, only one of which corresponds to heads, and she should reason as though randomly sampled from among them. What makes the puzzle so stubborn is that both camps can offer internally consistent formal arguments, and the dispute ultimately turns on exactly the same kind of question the cosmic duplication scenario raises, when there might be more than one instance of you, more than one waking, more than one located observer, sharing indistinguishable first-person experience. How are you supposed to reason about your own situation from the inside, when the inside feels identical no matter which instance you happen to be? Cosmic duplication is the Sleeping Beauty problem stretched out across space instead of across repeated wakings in time, and it inherits the same open, contested difficulty. Nobody has a fully agreed upon method for reasoning about your own likely situation once you stopped picking out a single, uniquely locatable observer. There's something about perfect duplication, even duplication, that technically preserves the philosopher's careful distinction between numerical and qualitative identity, that seems to undermine the felt specialness of being a particular, singular self, the specialness that seems to be doing a lot of quiet work underneath ordinary human self-conception, underneath grief, underneath ambition, underneath the entire practice of treating your own life as a story that matters because it is, in some deep sense, irreplaceable. Cosmic duplication, if it's real, suggests it might not be irreplaceable at all. It suggests that the specific configuration of matter and memory and personality that you experience as being you is not a singular, unrepeatable event in the history of the universe, but a pattern that, given a sufficiently large canvas to work with, was always going to get drawn again and again and again, not because of anything special about it, but simply because it is one finite pattern among a finite set of possible patterns, laid out across an infinite space that has more than enough room to run through every possibility in its deck repeatedly, forever. Now let's push the escalation one step further, into territory that most cosmologists find even more troubling than ordinary duplication, because it strikes at a much deeper worry, not just about whether you're unique, but about whether you can even trust that your memories and your sense of a continuous, orderly past are reliable at all. This is the problem of the Boltzmann brain, named for the 19th century Austrian physicist Ludwig Boltzmann, one of the founders of statistical mechanics, the branch of physics that explains large-scale thermodynamic behavior, things like heat, entropy, and the tendency of systems to move toward disorder in terms of the statistical behavior of enormous numbers of individual particles. Boltzmann's key insight was that the second law of thermodynamics, the law stating that entropy, roughly disorder, tends to increase over time in any closed system, isn't an absolute law in the way, say, conservation of energy is. It's a statistical tendency. Given a large enough number of particles, disordered arrangements dramatically outnumber ordered ones, simply because there are vastly more ways for a system to be disordered than there are ways for it to be ordered. Think of a deck of cards. There's only one way for it to be in perfect suited sequence, but astronomically many ways for it to be shuffled into disorder. So if you shuffle randomly, you will overwhelmingly land on disorder, not because disorder is enforced by any fundamental law, but simply because there's so much more of it available. Entropy increases, on Boltzmann's account, not because the universe is following some iron rule, but because disordered states are simply far more numerous than ordered ones, and physical systems left alone tend to wander into whichever state is statistically dominant. But, and this is the part that leads somewhere genuinely strange because it's statistical rather than absolute, the second law technically allows for rare fluctuations in the other direction. Given enough time, even a system that has settled into high-entropy disorder can, purely by chance, fluctuate briefly into a lower entropy, more ordered state, the way a shuffled deck of cards, if you shuffled it enough times over an absurdly long span, would eventually, purely by chance, land back in perfect order again, not because anything's forcing it to, but because with enough attempts, even the wildly improbable outcome eventually comes up. Apply that logic to the universe as a whole, and to the deep future in particular. Many cosmological models predict that the universe, as it continues expanding, will eventually settle into an extremely low-energy, high-entropy state often called heat death, a cold, dark, nearly featureless expanse stripped of stars, stripped of structure, essentially a very thin, very uniform soup of particles and radiation stretched out across an ever-growing volume of space persisting for a length of time so vast that the current age of the universe, 13.8 billion years, is a rounding error by comparison. In that state, Boltzmann's statistical fluctuations don't stop happening. They become vanishingly rare, but over a truly immense span of time, the kind of timescale physicists express using towers of exponents rather than ordinary numbers. Even vanishingly rare events occur again and again, given enough time to occur in. Here's the unsettling part. If you calculate the relative probability of two different kinds of fluctuation, a fluctuation large enough to produce an entire ordered galaxy full of stars and planets and, eventually, evolved brains like the ones we have versus a fluctuation just large enough to produce a single functioning brain floating alone in the void, complete with false memories of an entire life it never actually lived, memories generated instantaneously by the fluctuation itself rather than built up through years of real experience. The second kind of fluctuation is staggeringly, overwhelmingly more probable than the first. It takes vastly less improbable luck to randomly assemble one brain, complete with fabricated memories, out of background particles than it does to randomly assemble an entire galaxy's worth of ordered structure, stars, planets, billions of years of evolutionary history, and then a brain at the end of all that structure as a kind of afterthought. A single brain is a smaller, cheaper, statistically far more likely fluctuation to occur than an entire coherent universe. Physicists call the hypothetical entity produced by this kind of fluctuation a Boltzmann brain, a self-aware, momentarily conscious brain popping into existence out of background disorder, complete with a full, richly detailed but entirely false set of memories, believing itself to have a past, a body, a world, a night sky it once looked up at, and then, typically, dissolving back into disorder again almost immediately afterward because nothing sustains it, no metabolism, no supporting environment, just a fleeting statistical accident of matter briefly arranging itself into the shape of a thinking thing before drifting back into randomness. And in a universe old enough, or in an infinite universe which by definition has unlimited time and unlimited space in which such fluctuations can occur, the mathematics suggests that these spontaneously assembled memory-fabricating brains would vastly, overwhelmingly outnumber brains like yours and mine, brains that actually arose through billions of years of ordinary structured cosmic and biological history. It's worth dwelling for a moment on how genuinely counterintuitive this result is because on first hearing it, most people assume there must be some mistake, some sleight of hand in the reasoning. Surely, the intuition goes, a whole galaxy with its billions of years of ordered stellar and planetary history is somehow more natural to produce than a single isolated brain, materializing out of an undifferentiated soup of particles with no supporting structure around it at all. But intuition here is a poor guide precisely because it evolved to handle everyday probabilities, not the kind of astronomically lopsided comparisons that show up once you actually do the statistical mechanics. A galaxy's worth of order requires an almost unfathomably improbable fluctuation precisely because it involves so much matter arranged in so many mutually dependent, structured ways, stars, planetary orbits, chemical complexity, billions of years of stable conditions allowing evolution to proceed. A single brain, by contrast, requires far less matter and far less structure, and structure, in the relevant statistical sense, is exactly what's expensive. Fewer particles arranged into a smaller, if still highly organized, pattern is a comparatively cheap event, the way winning a small local raffle is a far less improbable event than being individually selected, atom for atom, out of every person alive on Earth. Both are wins. One is astronomically easier to get than the other. And when the deep future of the universe is imagined as an essentially endless span of near-empty, low-density space occasionally punctuated by random quantum and thermal fluctuations, the cheap event, the lone brain, ends up happening vastly, almost incomprehensibly more often than the expensive one. The whole ordered galaxy, however much more intuitively natural the galaxy might feel to us as the kind of thing that produces minds. This creates what physicists and philosophers of physics refer to, somewhat dryly, as the Boltzmann brain problem, and it's treated as a serious issue in cosmological model building, not a curiosity. Several cosmological models, including certain versions of eternal inflation and certain proposed futures for our own universe, have actually been challenged or revised specifically because they predicted Boltzmann brains would statistically outnumber ordinary observers by an enormous margin, which creates an awkward self-undermining situation. If a theory predicts that the overwhelming majority of conscious observers in existence are randomly fluctuated brains with fabricated memories rather than observers who arose through ordinary structured history, then a randomly selected observer, you for instance, right now, should, on statistical grounds, expect to be one of the Boltzmann brains rather than one of the rare, ordinary ones. Which would mean everything you remember, your childhood, the people you love, the sky you looked up at to start all of this, never actually happened. It would mean you are a fluctuation, a brief accident of disorder briefly resembling order, about to dissolve back into nothing, carrying memories that were never lived, only generated whole, in the instant of your improbable assembly. It's worth being very clear about the epistemic status of this idea because it's easy for it to slide from a serious problem physicists actually worry about when constructing cosmological models into something you should lie awake believing about yourself. It's the former, not the latter, and the distinction matters. The Boltzmann brain scenario isn't a claim that this is what's actually happening to you. It's a stress test for cosmological theories, a way physicists use to identify which models of the universe's long-term future are self-insistent and which ones predict absurd, self-undermining conclusions about the observers within them. Most working cosmologists treat a theory that predicts Boltzmann brain domination as a mark against that theory, a sign that something in its assumptions probably needs revision, rather than as an actual description of reality that we should update our beliefs to match. It functions less like evidence about your own status and more like a reductio ad absurdum used to rule out certain models of cosmic history. If your theory says most observers should be fluctuation brains with false memories, and that seems clearly false given that you can, right now, act on your memories and have them turn out to be reliably connected to a coherent, checkable world around you, then the theory has probably gone wrong somewhere and needs fixing rather than belief. Still, the mere fact that serious physicists have to build this kind of check into their models at all tells you something about how strained the terrain becomes once you let space and time stretch out toward infinity. Ordinary probability, the kind that reliably guides your expectations in ordinary, finite situations, starts to behave in deeply counterintuitive ways once genuinely unbounded quantities enter the picture, a fact mathematicians refer to as the difficulty of defining a sensible probability measure over an infinite set of possibilities, sometimes called the measure problem in cosmology specifically, and it remains one of the more genuinely unresolved technical puzzles in the field, not a matter of settled consensus at all. When you have infinitely many observers of one type and infinitely many observers of another type scattered through an infinite universe, comparing how many of each there are stops being a straightforward question, because infinity minus infinity or infinity divided by infinity doesn't behave the way ordinary arithmetic behaves, and cosmologists have proposed a range of different mathematical procedures for making sense of these ratios, called measures, none of which currently commands universal agreement. So even the claim Boltzmann brains would outnumber ordinary observers has to be handled carefully, because outnumber applied to two infinite sets isn't automatically a well-defined comparison at all. It depends heavily on which particular mathematical measure you choose to make the comparison, and different reasonable seeming choices can give different answers. There's a related tool philosophers and physicists reach for here, called anthropic reasoning, the practice of factoring in the fact that any argument about what kind of observer you should expect to be has to account for the reality that only certain kinds of observers are around to make the argument in the first place. The philosopher Nick Bostrom has written extensively on this, formalizing something called the self-sampling assumption, roughly the idea that you should reason as though you are a randomly selected observer drawn from some appropriately defined reference class of observers, and then ask what that implies about your situation. Applied to the Boltzmann brain problem, this is exactly the move that generates the discomfort in the first place. If fluctuation brains vastly outnumber ordinary evolved brains within whatever reference class you pick, then reasoning as a randomly selected member of that class should make you suspect you're a fluctuation brain, since most members of the class are. But Bostrom and others have also pointed out that this style of reasoning is notoriously slippery, sensitive to exactly how you define the reference class, exactly which observers count as relevantly like you for purposes of the comparison, and exactly which measure you use to compare infinite populations. Change any of those choices and the anthropic argument can flip, weaken, or dissolve entirely. This isn't a dodge, it's a real, live methodological difficulty at the heart of anthropic reasoning generally, and it's part of why the Boltzmann brain problem remains an active area of technical dispute rather than a settled conclusion anyone is actually asked to build their self-understanding around. That technical caveat is actually worth dwelling on for a moment, because it applies just as much to the earlier claim about duplicate Earths and duplicate U's as it does to Boltzmann brains, and it's the honest, responsible caveat that has to sit alongside the entire argument we've built up so far. The claim an infinite universe with finite local configurations guarantees repetition is mathematically sound as far as it goes. It follows from fairly basic reasoning about infinite sequences and finite possibility spaces, similar in spirit to the pigeonhole principle taught in elementary combinatorics, which says that if you have more pigeons than pigeonholes, at least one hole must contain more than one pigeon. Extend the pigeons to infinity while keeping the holes finite, and every hole ends up containing infinitely many pigeons. That part of the reasoning is genuinely solid, assuming its starting premises. But those starting premises, that space really is infinite, that matter really is distributed with statistical uniformity all the way out to infinity, that the basic laws and constants of physics don't change from one far-flung region to another, are exactly the parts that remain scientifically unconfirmed, and likely permanently unconfirmable given the particle horizon that walls us off from ever observing those regions directly. So the entire argument from duplicate Earths to duplicate U's to the Boltzmann brain problem should be understood the way a careful physicist would present it, not as an established discovery, but as a rigorous conditional, a genuinely serious if this, then that, built on premises that are individually reasonable, individually consistent with what data we do have, but collectively unverified, and possibly, in the strictest sense, unverifiable in principle, at least with any instrument or method we currently have any idea how to build. Which raises an interesting question of its own, sitting slightly to the side of the main argument: what should we do, intellectually and emotionally, with a claim that is logically rigorous, scientifically motivated, taken seriously by working physicists, and yet permanently beyond the reach of direct confirmation or refutation? Philosophers of science have long debated where exactly the line falls between legitimate theoretical extrapolation and unfalsifiable speculation, a question famously associated with the philosopher Karl Popper, who argued that falsifiability, the capacity of a claim to be, at least in principle, proven wrong by some possible observation, is one of the central marks distinguishing genuine scientific claims from ones that merely dress themselves in scientific language. My strict Popperian standard claims about the contents of space beyond the particle horizon sit in genuinely uncomfortable territory because no observation we could ever make, even in principle, could confirm or refute them directly. Some physicists lean on this to argue that multiverse and infinite space speculation, however mathematically elegant, has drifted outside the bounds of proper physics into something closer to metaphysics wearing physics' clothing. Others push back, arguing that these ideas aren't free-floating speculation invented for their own sake but natural, almost unavoidable consequences of theories like inflation, like general relativity's account of geometry, that were independently developed to explain data we can observe, and which happen to imply things about regions we can't observe as an honest byproduct, not as an added flourish. On this view, refusing to take the implications seriously just because we can't directly check them would be its own kind of intellectual dishonesty, cherry-picking the parts of a well-supported theory we like and discarding the parts we find uncomfortable. That disagreement remains genuinely open within the physics community, and it's worth holding onto both sides of it rather than resolving it artificially in either direction. But set the purely scientific question aside for a moment, because underneath it there's a philosophical question that doesn't actually depend on resolving the cosmology at all, and this is worth isolating clearly, because it's the part of tonight's train of thought that outlasts any particular scientific consensus. Even if it turned out by some future discovery that space is not infinite after all, that it curves back on itself, finite but unbounded, like the surface of that sphere Bruno's contemporaries imagined the heavens to be, the philosophical puzzle about identity and duplication wouldn't disappear. It would just lose its cosmic staging. Because the actual philosophical core of tonight's question isn't really about the size of the universe. It's about what personal identity consists of in principle, and whether the concept can survive contact with the mere possibility of exact duplication, wherever that duplication happens to occur across cosmic distances, in a Parfit-style teleporter, in a hypothetical brain-scanning machine, or nowhere at all, purely as a thought experiment run entirely inside a philosophy seminar room. And that question turns out to matter for reasons that have nothing to do with astrophysics and everything to do with how you actually live. Consider what's really being asked when you ask which one is me. Most people, encountering the question for the first time, assume there must be a fact of the matter, some further truth beyond the shared memories and the identical personality and the matching physical structure that settles which one of the duplicates is the real, original, authentic you, and which one is merely a copy, however perfect. That assumption is worth examining directly because it's doing an enormous amount of quiet work, and philosophers like Parfit spent careers arguing it might simply be false, not unanswered, but based on a false premise to begin with, the same way what is north of the North Pole isn't a hard question so much as a malformed one built on a picture of the world that doesn't actually support the kind of answer it seems to be asking for. If Parfit is right, then the search for a determinate fact of the matter about which duplicate really is you is chasing something that was never there to find even before any cosmology gets involved. What you actually are, on this view, isn't a metaphysical essence occupying a body like a ghost occupying a house, capable of being definitively located in one place and only one place. What you are is a pattern, a specific, richly structured configuration of memory, disposition, personality, and continuity, and that pattern doesn't come with a serial number attached, no unique identifier distinguishing the real one from any qualitatively identical instance of the same pattern occurring elsewhere. On this account, if two instances of that pattern exist, there aren't two answers to which one is you. There's no coherent question there at all, only two people, both with an equally legitimate, equally complete claim to being a continuation of everything that pattern contains, neither one more authentic than the other, because authenticity was never the kind of property this situation has room for in the first place. That's a genuinely difficult thing to sit with because it cuts against something that feels, from the inside, like the most obvious fact in the world, the sense that there is, undeniably, a single me experiencing this exact sentence right now, a single unified point of view that could not possibly be shared or doubled without something essential being lost or violated in the process. But notice that this feeling, however strong, isn't itself an argument. It's a report on how identity feels from the inside, and Hume, centuries before any of this cosmology existed, already raised the possibility that this feeling of a single unified self might be something closer to a compelling illusion than a metaphysical fact, a story consciousness tells about itself, convincingly enough that questioning it feels almost impossible from within, but a story nonetheless built out of continuity of memory and habit rather than out of some underlying, indivisible substance that duplication would actually threaten. There's a way to make this less abstract, and it's worth doing because tonight's whole train of thought has a way of floating up into pure abstraction if you let it, and the floating is itself a kind of evasion. So bring it back down to something concrete. Imagine, not across cosmic distances but right here, tomorrow morning, that you woke up to learn that overnight, through some process nobody fully understands, a second version of you had come into existence, same memories up to the moment of sleep, same body, same everything, now standing in your kitchen, equally convinced of being you, equally shocked to discover there are two. What would actually be lost? Not practically, this would obviously create enormous problems, legal, social, personal, but at the level of whatever it is people are actually afraid of when they recoil from the idea of duplication. Would anything about your own life, your own memories, your own relationships become less real, less yours, simply because an identical set of them now also belong to someone else standing across the room? Your love for the people you love wouldn't transfer to the copy or diminish in you. Your specific, lived experience of every day up to that point remains exactly as fully, completely yours as it always was. What would actually change is only what happens going forward, two diverging lives, two diverging sets of new experiences, starting from an identical launching point and immediately beginning to differ, the way any two lives differ once put in different rooms. It's worth being honest, too, that not every philosopher who has looked at this closely lands where Parfit does. There's a long tradition, running from certain readings of Descartes through to some contemporary defenders of what's sometimes called a further fact view of personal identity, that resists the idea that identity can simply dissolve into a matter of degree, into psychological connectedness that branches without any determinate answer about which branch is really you. On this competing view, there really is a further fact about which continue accounts as you, even if we can never discover it, even if the physical evidence available in a duplication case would be identical for both candidates. The world itself, on this account, still contains a genuine, if inaccessible, truth about which one you actually are, the way the world contains a genuine truth about the location of a coin at the bottom of a lake, even if no one will ever retrieve it to check. This isn't merely a stubborn refusal to accept an uncomfortable conclusion. It rests on a real intuition many people share strongly, the sense that consciousness itself, the specific first-person fact of experience happening from exactly this vantage point rather than some other, is not obviously reducible to any third-person description of memory, personality, and physical structure, no matter how complete that description gets. If that intuition is right, then even a perfect physical and psychological duplicate might fail to carry your consciousness forward with it. In some sense, a duplication argument built entirely on physical configuration can't settle either way. Nobody has resolved this dispute, and it isn't obvious it can be resolved through argument alone, since both sides can, in principle, agree on every physical fact of the case and still disagree about what those facts add up to. That unresolved tension is worth carrying forward rather than papering over, because it means tonight's question doesn't actually have a tidy philosophical consensus waiting at the bottom of it. It has two serious, competing pictures of what a self even is, and the cosmological scenario simply forces a choice between them that ordinary life rarely demands. If Parfit's picture is right, though, and it's worth noticing this is close to his own eventual position, argued at great length and with considerable personal conviction, then the discovery of a duplicate, whether next door or across the unreachable breadth of an infinite cosmos, doesn't actually steal anything from you. It doesn't retroactively make your past less real, your memories less genuinely yours, your identity somehow counterfeit because it turns out not to be metaphysically unique. What it challenges is a specific and, on reflection, somewhat parochial assumption, the assumption that uniqueness is what makes a life matter, that meaning requires being the only instance of a pattern rather than one instance among possibly many. And that assumption, once you hold it up to the light, turns out to be doing more work than it can really justify. A sunset over the ocean isn't rendered meaningless by the fact that a nearly identical sunset happened yesterday and will happen again tomorrow, and has happened, in close variation, every evening for as long as the ocean and the atmosphere have existed roughly as they do now. The particular sunset you watch is still the one you watched. Its meaning to you was never contingent on it being the only sunset in the history of the universe. Why would a life be different once you actually interrogate the assumption rather than simply feeling its weight? This has a practical edge worth drawing out because the temptation, once you've absorbed an argument like this, is to let it collapse into a kind of shrug. If there are infinitely many of me anyway, why does any particular choice, any particular effort, any particular kindness or cruelty matter at all? That temptation is worth resisting directly because it rests on a slide the argument doesn't actually license. Even granting every premise about infinite duplication, nothing about it implies that your choices are somehow being made elsewhere on your behalf, freeing you of responsibility for the ones made here. The duplicate elsewhere, if it exists, is making its own choices, shaped by its own local circumstances, diverging from yours the instant any difference, however microscopic, a stray cosmic ray, a difference in some quantum event neither of you could ever have controlled, enters the picture. Its existence doesn't run your life in parallel on some kind of cosmic autopilot. It doesn't absorb the weight of what you do here in this one instance of the pattern, which is the only instance you will ever have any access to, any influence over, any responsibility for. If anything, the argument cuts the other way. Derek Parfit himself, late in Reasons and Persons, argued that a reduced, less metaphysically inflated view of personal identity, the very view this whole cosmological scenario seems to force on us, should if anything widen the circle of what you care about, rather than shrinking your care for your own single thread of experience down to nothing. If the sharp boundary around yourself, the boundary that made your own future matter so much more than anyone else's, turns out to be less solid than it felt, less a metaphysical wall and more a psychological habit, that doesn't obviously make your own life matter less. It suggests the lives around you, the people who don't share your memories at all, might matter comparably more than a strict wall-building notion of self had made it easy to feel. There's also a version of this that comes up constantly in conversations about artificial minds and digital copying, worth mentioning briefly because it shows the same puzzle isn't confined to cosmology at all, it's becoming a live practical question much closer to home. If a sufficiently detailed scan of a brain could someday be run on different hardware, producing a functioning mind with all the same memories and dispositions as the original, every one of tonight's questions resurfaces immediately, minus the impossibly large distances. Would the copy be a continuation of the original person, or a new person who merely inherits their memories, the way an heir inherits a house without becoming the person who built it? Would running two copies simultaneously mean there are now two people with equal claim to a single life's worth of history, or one person somehow smeared across two locations? Philosophers working on the ethics of mind uploading and digital duplication have inherited essentially the same conceptual toolkit built for cosmic duplicates and teleporter thought experiments because the underlying structure of the puzzle doesn't actually depend on the distances involved. Whether the duplicate is 10 billion light-years away or running on a server in the next room, the philosophical question is the same question, wearing different clothes. Cosmology just happens to be the version of it that arrives already built into the physics, without anyone needing to invent a machine first. There's a further, more unsettling turn worth taking before we close, because it connects the cosmic scale back to something closer to the ground, something that doesn't require infinite space at all, only ordinary probability operating over ordinary stretches of time. Even setting aside cosmic duplication entirely, even if it turned out space is finite after all, human history on this one single planet already involves something not entirely unlike this puzzle, in miniature. Every person who has ever lived has been, in a strict sense, entirely unique in the details. No one has ever had your exact combination of experiences. But the raw material out of which any given life is built, a finite set of possible personality traits, a finite range of possible formative experiences, a finite palette of joys and griefs and turning points that recur across billions of human lives, generation after generation, means that lives resembling each other in striking, sometimes uncanny ways have almost certainly occurred before, will occur again, are perhaps occurring somewhere on Earth at this very moment, without any of that similarity threatening anyone's sense that their own particular life is the one they're actually living, the one that actually matters to them, regardless of how many broadly similar lives have unfolded elsewhere. Uniqueness down to the last exact detail was probably never really the thing doing the work of making your life feel worth living in the first place. Something more local was always doing that work, the fact that it's the one you're in, the one you're living forward from the inside, one choice and one morning and one memory at a time, regardless of how many structurally similar stories are unfolding elsewhere, on Earth, or, if the physics holds, on some unreachable Earth billions of light years past the edge of anything anyone will ever see. There's one more strand worth pulling before we come back down to the ground, because it bears directly on what to actually do with an idea this large, once the thinking is done and the ordinary business of being a person resumes. Philosophers and scientists who spend serious time with ideas at this scale, cosmic infinity, deep time, the sheer indifference of physical law to any individual observer's importance, often report something psychologists have started calling cosmic awe, or, in some of the research literature associated with figures studying the psychology of awe, overview effect style experiences, after the reports of astronauts who described a profound shift in perspective upon seeing the Earth from orbit for the first time, small and whole and undefended against the black behind it. What's notable in that research is that the dominant emotional response to genuinely confronting scale like this isn't usually despair, even though despair is the response most people brace for in advance. It's more often something closer to a paradoxical enlargement, a shrinking of the individual ego's sense of self-importance running alongside, not against, an increased sense of connectedness, curiosity, and even tenderness toward the fact of existing at all, however briefly, however locally, in however vast and indifferent a setting. Or, on this account, doesn't erase the self. It resets the self's sense of scale, and in doing so, strips away some of the narrower anxieties that only make sense at ordinary, human-sized dimensions, status anxieties, grudges, the accumulated weight of small daily frictions, while leaving intact, or even sharpening, the more fundamental attachments to people, to particular mornings, to the specific, non-negotiable fact of being the one having this experience, right here, right now, regardless of how many structurally similar experiences might be unfolding elsewhere, unreachably, in the dark. That's worth holding onto deliberately, because the natural end point of an argument like tonight's, followed carelessly, is a kind of numbness, the sense that if there are infinitely many of everything, then nothing in particular matters, since nothing is unrepeated, unprecedented, or safe from duplication. But that numbness doesn't actually follow from the argument. It's an emotional overcorrection, mistaking a claim about physical repetition for a claim about value, when the two were never the same claim to begin with. The rarity of a thing and the worth of a thing have always been logically separate, even in ordinary life, long before any cosmology entered the picture. A parent's love for a child was never contingent on that child being the only child who has ever existed with that particular laugh, that particular way of falling asleep in the car. Meaning, as most people actually practiced it, was never built on cosmic uniqueness. It was built on relationship, on presence, on the accumulated weight of specific shared time, and every one of those things survives fully intact whether or not some unreachable configuration of matter 10 to the power of an unwritable number of meters away happens to be running an identical pattern through an identical set of motions, utterly unaware that this conversation on this side of the universe is even taking place. So here's where this leaves us, standing back outside, under the same sky we started with, having traveled, in thought only, but honestly, from the ground beneath your feet out through the solar system, out through the galaxy, out to the edge of everything any instrument will ever detect, and then, following the logic as far as it honestly goes, out past that edge entirely, into a region cosmology can describe mathematically but never observe, where, if the premises hold, the same finite deck of possible configurations gets dealt out again and again across an infinite table, producing, somewhere among its infinite hands, another planet exactly like this one, and on it, another brain holding an identical, unbroken thread of memory running from an identical childhood up to an identical night spent looking up at an identical sky, thinking, in that instant, an identical version of this identical thought. It's worth being honest about the limits of that if one final time, because it's easy for a piece like this to leave the impression that physicists have quietly confirmed the existence of your cosmic twin and are simply waiting for better telescopes to prove it. That isn't the situation. What's actually been established with reasonable confidence is more modest and, in its own way, more interesting, that our best current measurements of the universe's geometry are consistent with infinite flat space, that leading models of the universe's earliest moments, independently developed to explain things we can directly observe, tend to imply a cosmos far larger than anything within our horizon, and in many versions unbounded, and that if those two things are true together, along with the uniformity we already observe holding within our own horizon, then elementary probability, not exotic new physics, forces the conclusion about repetition. Every link in that chain is defensible. None of them is proven beyond the reach of future revision. Cosmology is a young science working at the very edge of what evidence can reach, and it would be a mistake to treat any single chain of reasoning this length, however carefully built, as a closed case rather than as the genuinely serious, genuinely open possibility it actually is. But notice that the uncertainty itself doesn't fully dissolve the vertigo, and that part of what makes this particular idea so durable, so much harder to shake off than an ordinary piece of speculative trivia. You don't need certainty that your cosmic duplicate exists in order to feel the floor shift a little at the mere coherence of the possibility. It's enough that serious people, working with real data and rigorous mathematics, cannot currently rule it out that the honest answer to does another version of me exist somewhere past the edge of everything we'll ever see is neither yes nor no, but a carefully qualified maybe, resting on premises that are individually plausible and collectively untestable, perhaps permanently. That kind of irreducible uncertainty sitting at the largest possible scale, applied to the smallest, most personal possible question, not what exists but what am I, and is there only one of it, has a way of staying with you long after the specific numbers and the specific physicists' names have faded, the way a splinter stays interesting long after you've forgotten exactly how it got under the skin. If that person exists, and it's an if, carrying real scientific uncertainty in both directions, not a settled fact to build a worldview on, but a serious enough possibility that serious physicists spend careers working out its consequences, they are not a copy of you in any sense that made you first and them second. There was no first, no sequence, no original, no delay. Just two instances of the same pattern, arising independently, each one anchored entirely in its own local stretch of space, each one carrying the complete and, from the inside, entirely convincing sense of being the one who is really doing the experiencing, the one who is really standing here, the one this all is actually happening to. So if somewhere out there, past every horizon any telescope will ever reach, another person is standing under another sky made of the same matter arranged the same way, holding your exact memories, thinking your exact thoughts, right down to this one, at this exact moment. There's no trick answer waiting at the end of that question, no clever resolution that makes the discomfort go away for good. That's not a failure of tonight's argument. It's the actual shape of the problem, honestly reported rather than smoothed over for the sake of a tidier ending. Every framework brought to bear on it, Locke's memory theory, Hume's bundle of perceptions, Leibniz's insistence that no two things can share every property, Parfit's careful dismantling of the assumption that identity has to be all or nothing, the competing further fact view that refuses to let identity dissolve into mere psychological connection, gets you partway somewhere, illuminates some angle of the difficulty, and then runs out of road before delivering a single, settled verdict everyone can agree on. That might be the most honest thing to take away from all of this, not a conclusion, but a sharpened question held up against a backdrop large enough to make it feel newly serious, even though some version of it has been asked in one form or another since at least Lucretius stood somewhere without a telescope and reasoned his way to the same unsettling place using nothing but atoms, void, and the plain refusal to believe infinity would leave anything unexplored. Maybe the honest response, standing back under that sky, isn't to resolve the question at all, but to notice what it does and doesn't change about the person doing the asking. It doesn't change the fact that this is the only vantage point you have ever had access to, or ever will. It doesn't change the fact that whatever happens next, the next conversation, the next choice, the next ordinary morning happens to you from inside this one instance of the pattern, regardless of what any other instance, real or hypothetical, happens to be doing at an unreachable distance you will never close. It doesn't make the specific weight of a specific memory lighter or a specific relationship less irreplaceable in the only sense of irreplaceable that was ever actually available to a finite creature living inside a nearly infinite universe. Not that nothing like it exists anywhere else, but that nothing like it exists here in this life except through you. So look up again if you're somewhere that allows for it. The sky hasn't changed since the beginning of this. It's the same points of ancient light, the same borrowed glow from stars that may not even still exist in the form that light left them in, the same overwhelming, wordless suggestion of scale that started all of this in the first place. What's changed, if anything has, is what you now know sits behind that scale, not just distance, not just galaxies stacked on galaxies, but the live, serious, still unresolved possibility that somewhere past every horizon anyone will ever reach, the exact shape of this exact moment is happening again to someone who is, by every measure physics has, entirely and legitimately you. And the question that leaves behind isn't really about them, whoever or whatever they are, out there, unreachable, unaware. It's about what you decide to do with the one version of this you actually get to live, the only one, as far as you will ever be able to tell, that you'll ever have any say in at all.